Hello, everyone. Welcome to your Building Hybrid Networks Connectivity with AWS. I got networking people here. Yes? Okay, good. Thank you. I feel at home. So, my name is John, and I'm an instructor with AWS. If you don't know a little bit about me, so I used to be a dev, and then I took a little bit of a weird path, and I became a network admin. I know that makes no sense. But basically what I used to say is, you don't know what you're doing, network people. My code works perfectly. Your thing doesn't work. So let me go and become a network admin. I was wrong. It was my code. Then I thought, well, it's not the network, it's the servers. So I became a sysadmin. I was wrong. It was me. So I moved around a little bit, became an SA, or an architect, solution architect with AWS in 2016. And then they said that I talked too much, so they shipped me into the training team, who then said that I talked too much, who shipped me into the evangelist team, who said I didn't talk enough, so they shipped me back to the training team. So I'm back as an instructor, and then today I'm going to talk to you about networking. So that's what we're going to do. I got a few jokes for you. Hopefully you're going to laugh. If you don't laugh, then that's probably a UDP joke, because you don't get it, right? Right. Oh, wow. Okay, tough crowd, tough crowd. We're going to see if I can make that better as we go. So, what do I have for you here? So, some stats coming out of Gartner right here, Gartner Market Trends, that said that 88% of enterprises that have a cloud-first strategy, but 86% are still on-prem. Sounds weird. So maybe we need to do some hybrid then. Because if you still are on-prem at 86%, maybe we're going to need to figure out how we're going to connect the on-prem to AWS. So that's what we're talking about inside of this session today. So the complexity of a traditional networks, we know this. So a bunch of data centers in a bunch of places. We got some remote worker right here, and then maybe they are connected over a VPN. We also have some branch offices that are connecting somewhere. We got some warehouses that are maybe connecting over a VPN. Maybe they have a direct line. I don't know how they're connecting, but somehow they're connecting. And then all of them need to be able to go and talk to AWS, so that makes it a little bit harder. So how do I solve this? How do I go about this? Well, moving towards a cloud-centric model where I got AWS in the middle. Wait, AWS is not a transit center between data center and branch offices. Maybe it can. We'll see. AWS can't, go out and connect to my warehouse, and I can't use a VPN for my remote worker or from my warehouse. Maybe it can. We'll see. So all of that gets connected towards AWS, and then one of the nice things about AWS is we have a global infrastructure. This global infrastructure, let's go and take a look at it right here. So global infrastructure of AWS, I like this one, it's a little bit more updated. We got 32 regions across the world. So that's fine. Okay, so those are the points right there. So by the way, I'm from Canada, so I really want Canada West to arrive, and it says coming soon. So I keep clicking on it, so maybe it was today. It was not. So I'm still waiting on it. Back in 2016, Canada West, because apparently, Canada Central, because apparently that's central part of Canada. That's fine. Canada Central is right over there. It launched in 2016, and then in December 8, 2016 is the exact date. I remember I had to pick up my CTO from the airport. That was scary. And then, Canada West, hopefully, maybe it's going to make it on the same date. I would really like that. Maybe they play a game. I don't know. End of December 2020, end of 2023, beginning of 2024 is the actual word on the street or on our blog post. So that's the global infrastructure, but there's a bunch of places that are missing in there. There is 600 points of presence. Points of presence, that's a little bit different. The points of presence allows us to be across the entire world, and then if we go and look a little bit at that, I need a keyboard. So if we go and check out CloudFront, for example, let's go and take a look at that. Edge locations. All right. So that's the infrastructure of CloudFront, and that's actually what's inside of the slides. So the slide shows us the edge locations of AWS. Much more important because there is networking that is there. Edge locations aren't owned by AWS. We have hardware in those locations. Edge locations are also called points of presence, POPs. So tier 1, tier 2, tier 3 service providers. So where we have hardware in those locations, we connect with them directly. And then that is going to help us across these this next hour together to figure out what we can do with this infrastructure. So remember, we have the regions, and then we have the edge locations that are much closer to the individual users, because there's way more points everywhere than when I actually look at the global infrastructure that was right here, where there's a lot less point, or only 32 regions across the world. So sometimes we want the data to go towards a region before hitting somewhere else. Sometimes we hit an edge location. So I'll come back on that. But to make this a little bit more interesting, I have a great use case for you. I don't know if you know this company. It's called Any Company. So it has a story. So here's its story. I lost my pen. There it is. It has 2 data centers. It wants to get started on migrating towards AWS. Okay. It aspires to scale business globally. Globally. It means maybe we're going to need to be in more than one region. We're going to see that. And it is regulated. Well, no, this part kind of says, can you please do some encryption for us? So that's that part. Everyone should be doing encryption. It doesn't matter if you're regulated or not. So help me. So how do we get started is where we want to go. So I got the AWS cloud on the left-hand side, 2 data centers on the right. Well, that's normal. We said 2 data centers. So how do we get this going? Connectivity using site-to-site VPN. So I'm going to help us out here and then start with one region. I got one region. This one region, I want to connect it towards those data centers. Right? They want to scale globally, which means probably one more region, but we're going to start with one for the moment. They have 2 data centers, and we need to connect in there. So how do we do that connection? Well, we have a VPC. So virtual private cloud. Inside of the region, I put a CIDR block, and then inside of that CIDR block, we define where and how it should get connected. So we're going to need something in there that's called a virtual private gateway. We're trying to do a VPN. So we need a VGW, virtual private gateway. Next thing that we need is actually something, well, sorry, before I go there, a VPN or our virtual private gateway has termination endpoint, and those have public IP addresses. Anyone knows if it's, let me go back to that. So we have one private endpoint right there. I got the customer gateway, and then once we have the customer gateway, we can establish a VPN connection. This VPN connection has a maximum of a 1.25 gigabit per second. You cannot go above that for the moment. So I got an IPsec tunnel. It's connected. It's over into one public IP. But that's only one VPN endpoint. VGW, anyone knows how many endpoints we give you? 2, so we need another one, so let's add another one. Oh, sorry, that's over the internet, by the way. So we need another one, so connect these 2, but these 2 are connecting to the same customer gateway, the same public IP on this side. So that's how we got connected. But what about the other data center? Well, the other data center also needs to get connected, so we got 2 more endpoints. towards the other public IP address. So this is a different public IP on the other side, and that's a customer gateway. You give it an IP address, you tell us what it is, and then we establish IPsec tunnel all over the internet, and now we're connected. Is that it? Is that all they're going to create? Or will they have more than one virtual private cloud? Huh. More than one, probably. More than one. That's 4 more links. Are we done? No, there's a bunch of space in my slides still. So, how about another region? Ooh. Oh, this is no fun. So, how do we calculate how many links that we need? Well, this is the math. An IPsec connection equals the number of data centers times the regions times the amount of VPCs. That's the amount of connections, of IPsec connections, that you need to have up across this. That is a lot of work. I got a joke for you, if you want to hear it. It's, do you know why did the VPN break up with the firewall? No? It's because it felt too restricted, so it needed to connect to other networks. Oh, okay, fine. I'm gonna get there. I'm gonna get clapping at some point. It's gonna happen. So, we need a way to solve this problem, like the VPN that broke up with the firewall. So how do we solve this problem? Well, the way that we're going to solve it now is use Transit Gateway. Of course, this is where I was going. So now that we have Transit Gateway, it simplifies everything. With Transit Gateway, we still need a customer gateway on the other side. It's still using site-to-site VPN, the same tech of site-to-site VPN, the same idea, the same way, but now we're connecting towards that Transit Gateway. Still 1.25 gigabit per second of maximum per connection. But instead of having a ton of them, well, sorry, I also need the other side, right? I'll take care of the other side. But now I can connect all my VPCs inside of that region towards that Transit Gateway. Transit Gateway, though, is that a regional service or is that a global service? Regional, I've put it inside of the region. So yes, I've already solved that answer. So we need another Transit Gateway at the bottom. So that's why I have that there. But there's something magical that just happened on top of this. On top of solving all of these links, right? We have a lot less links now. In fact, the multiplication is just data centers times region. It's no longer data centers times regions times VPC, data center times region. The other thing that Transit Gateway adds is things like multicast. You can do multicast across it if your application still uses that. You can do things like ECMP, equal cost multipath. We can now go above the 1.25 gigabit per second. Ah, that's interesting. You see, now that I have 2 links across these, I can go to 2.5 gigabit per second per VPN connection. Why? Because remember that I had high availability on this end. We gave you 2 endpoints, but these 2 endpoints now we can use both of them together. So we can go to 2.5 gigabit per second. You can do this quite a lot, all the way up to 50 gigs of traffic through that Transit Gateway. So that's a lot of connections to establish, but that will allow you to get to the amount of traffic that you wanted to. But as any great companies out there, the requirements changed. And then it said, now we want to connect branch offices that are in different locations with VPNs. How can we provide consistent performance? Ooh, we have a new requirement now. Earlier it didn't say I needed consistent performance. Earlier it said, I want to migrate data towards AWS, and I want to do this fast. And now we need to start getting onto doing this. So the way that we can solve this could have been through Direct Connect, which is a service, and I'll explain that later on, but it's a service that we can get directly connected towards AWS, but that takes a little bit of time to get set up. So that's the reason. Now, why do we talk about consistent performance? Because there's no problem about this diagram. Where's the problem? There's one problem. There's a second problem. It's one problem. It's the internet. Oh, that internet. It has a lot of jitter. The latency goes up, and it goes down, and it goes up, and it goes down. Why? Well, let's look at an example. Here's an example. I'm showing you some autonomous systems, some AS numbers in there. When you have this customer gateway on the right-hand side that is connecting towards a transit gateway, it doesn't directly connect to it. It passes through a bunch of AS numbers in there. And then now, because BGP is around, it figured out that, look, there's a path from ISP number 1 through this autonomous system over there, and then we pass through this one, and then now we're able to get to the transit gateway. So everything is fine. And then someone just dig a hole, and then they cut the fiber. So now we're passing through all of those AS numbers, all of these networks, and then my latency just went up. Latency goes up and down, depending on how many holes you dig in the ground. Or fiber cuts, or rerouting, or one company doesn't want to talk to another company, or someone injects some routes that makes no sense, or it all. There's a lot of reasons. But that's a problem. So how do we solve this problem? Well, to solve this problem and get consistent performance, I could use Direct Connect. No, Direct Connect, we want to go fast. The problem with Direct Connect is it takes a while to set up. Not from an AWS perspective. For us, pretty easy. Within 24 hours, we give you a letter of authorization, an LOA, and then we give you a port on a router in a location of your choosing. Okay, so how do I connect to that port? That is your problem. That's not my problem. Ooh. So you mean I'm going to run a fiber cable all the way there? Yep. I hope you have a lot of fiber. But how could I still use Transit Gateway, but do this in a way that is going to have less of these AS numbers, right? All of these autonomous systems, all of these networks that I'm traversing. How could I get on and get to this number, right? The network of AWS, much closer to where this office in the EU is. This is in a region, right? What else did I talk about from a global infrastructure perspective? POPs. Exactly. Points of presence, edge locations. These edge locations, they're everywhere in the world. They're much closer to our customers. So let's go and take a look at them again. Oops, sorry. Can't move up. Come on. All right, so much closer to all of our customers. We have all of these points of presence across the world. What if I could get onto an edge location, and then now from this point on, I'm on the backbone of AWS. I'm no longer using the internet. I'm still using the internet, a little bit of it. And then that little bit, sorry, I'm going back, that little bit is going to be, I'm going to come back on that setting, to get to an edge location, to arrive to the AWS backbone. The technology being used in there is called Global Accelerator. Global Accelerator is a service that you can use to do and get to Global Accelerator and point towards different IP addresses, things like towards AWS, things like ALB, things like EC2 instances, any IP addresses that you would like, really, in the backend. It's similar to like CloudFront. But CloudFront, which is a content delivery network, a CDN, it does caching. It's all about HTTP and HTTPS. But what if my application uses TCP or UDP? Well, I could use Global Accelerator. And Global Accelerator works with site-to-site VPN. So the way now it works, instead of using the public IP addresses on this side, we now give you Anycast IP addresses. The same IP address across the entire world. When you hear a joke about Anycast? I got a good joke. Why, sorry, I had it written somewhere. Oh yeah, why did the network engineer use Anycast for his vacation? Because he wanted his packets to have a destination, but didn't really care which resort they ended up at. Because the idea, thank you, because the idea is you hit these IP addresses, but it doesn't matter where you end up at. So it's the same IP addresses. We give you these same, so whatever you configure your devices on the right-hand side, your customer gateway, it's going to be the exact same IP addresses, which are anycast, same IP addresses across all of our edge locations, so that, or in points of presence. So then when you get to the closest points of presence, from there, all the way to the region of AWS, we're using the AWS backbone. That's the thing that keeps our performance consistent. Because the only part that is on the internet is the part between you, your data center, ISP, and then your ISP is probably connected into AWS already at the closest point of presence. So a lot less of different networks and skipping over and then re-triggering across different AS numbers and whatnot, right? So we're getting through that a lot faster. So that's the idea of using Anycast at this point. So acceleration of this. All right, that took care of everything, I think. Well, maybe not. We got yet another requirement. Here's the next requirement. Our workforce is largely remote. How do we securely give them access to our cloud workloads? Well, you didn't say that in the beginning. I created a site-to-site VPN. Well, why not create a site-to-site VPN for every one of our remote users? That's not a site-to-site VPN. Like, that's a remote worker. Like, that's not how it works. So what we're going to do is we will still use Transit Gateway in some way to get towards these VPCs. Because these remote workers on the right-hand side, they want to get access to some apps that are currently inside of these VPCs. So to have access to something that is inside of this VPC, well, one way that you can do that is put an elastic IP address, a public IP address, off of this EC2 instance that's underneath there. And then now you can have these users use the internet to get access to it, but that wasn't our point. What we wanted to is we want to make sure that we can get from these remote users and get them inside of our environment. So we're going to use an open VPN client. Any open VPN client, even ours, because we do have one, the AWS Open VPN client. And then from there, you connect into something that's called an AWS Client VPN over the internet, right? I mean, your remote workers are over the internet. And so we get them connected to that client VPN, which is inside, that should be inside of the region, but that's fine. So that should be inside that icon inside of the region. And then now once they're connected, we need to authenticate them first. SAML 2.0, Active Directory, or mutual SSL, or mutual certificates, mutual SSL authentication, or TLS authentication that you can do there. So those are the three ways that we're going to authenticate users. Right, the SAML, or Security Assertion Markup Language, or Active Directory is really to be able to just do single sign-on from whatever normal username and passwords that they use to authenticate to their laptop in the first place. Once they're authenticated, then we're going to need something. And that something is called an AWS Client VPN VPC. So we'll create, and that's the best practice, by the way. So we shouldn't be reusing the VPC 1, 2, and 3, which are our application VPCs. You should create and dedicate maybe one VPC for them. And then inside of that one VPC, we're going to need a few things. We're going to need some subnets. So we'll create these subnets. We call those target networks. Target networks, not as these. This is not a target network. That's a destination network. Difference. Target network is the subnets that you see here. And whenever you pick these subnets, we actually create something that's called an elastic network interface, a network card. We put a network card inside of the subnet. The more subnets you add, the more clients and concurrent connections we can have. The only issue is that you can only have one subnet per AZ, per availability zone. That limits things a little bit. In regions like Canada Central, which only has 3 AZs only, that means, well, the number is eluding me. So 1 is something like 6,000, 7,000 connections. 2 subnets, you're highly available, you get 36,000. Another one after that, I think it's plus 35, so around 60,000 something different connections that you can have with your 3 subnets. So If you need more than this, well, we're going to need another AZ, and, well, you can't have another AZ in there. So that's the maybe danger with client VPN, depending on the amount of clients that you actually have on the other side. Now that we have the clients and then an ENI in there, we're using, we should connect the VPC, the client VPC, VPN using Transit Gateway, because we don't want to be using VPC peering or any of that. And then after that, you need to understand that we're using something that's called source NAT. So all the traffic of every one of these clients are going to look like they're coming out of these two elastic network interfaces. ENIs in AWS have security groups, which means that I can have a security group attached to these ENIs, and then on these other VPCs or these other applications, I could be saying only traffic from these security group. So that will allow you to get them inside of these applications that you see there. So that's the idea. It does use source NAT for us. Once that's done, we're going to need to configure some authorization rules to say, well, these clients, whomever these clients are, now that I've authenticated them, what are the destination networks? Which VPCs are they allowed to have access to? That actually creates a route on their computer. Once the route is added inside of their computer, well, now they can have the access. Until the route is added by client VPN, then that's not going to work and they're not going to be able to access the other side. So we've taken care of how to get the clients, the remote users, to connect into our region, into this VPC. Now, this transit gateway that's right there, I know how it's connected right now, but if they needed to have access to another region, you can peer transit gateways together, which would mean that now, because they're coming out of this CNI, they would go through the transit gateway into the other transit gateway in the other region, which would then allow you to go to a VPC inside of another region, for example. All right. Next requirement. We moved more workloads to AWS. Now, we need to achieve more cost-effective and consistent performance. Because we achieve consistent performance from site-to-site VPN using Anycast, right, using Global Accelerator. But now, I need to have these clients connecting, or these sites connecting, but I need to do this in a more cost-efficient way. Let's add Direct Connect now. So, Direct Connect is one thing that we can add. It's a physical connectivity using physical link in between your data center and then, I messed that up, between your customer router and your AWS router on the other side. Because remember, I said that earlier, when you order a dedicated connection, a physical connectivity using AWS Direct Connect, we give you a port on a router in a location. That's a lot of A. We'll come back on that later, right? The high availability, but we'll come back on that. So, customer router to the customer router on your side, get to your customer router. How you do this, don't know. That's your problem. But this part, we gave you this little port that was right there, and then that's how you can connect to it. So once you're connected, well, once you're connected, if you use different, depending on the speed that you've used, we can enable some encryption. This encryption is using MACsec support, and MACsec support is only available for 10 gig and 100 gig depending on the location. So if you're using a 1 gig connection, MACsec support doesn't work. And this only works with dedicated connections, because we're going to talk about something else in a moment. But once I got this, then I'm using encryption in between. So the idea is I'm using, with my MACsec support, the encryption here. That's encrypted. What about this part? Again, that's not my problem. That is your problem between what you do on your data center all the way towards that customer router on your side. Well, how am I going to be able to bring my own customer router in this location? Again, that's on you to figure it out. That's on you to go and rent a cage in the same Direct Connect location, because there's a bunch of Direct Connect locations. Here they are. So lots and lots of them. So let's go to Canada, because that's where I'm from. So a little bit less of them, but 250 Elliott Street in Toronto, and that's fine. And then you see, like, we have the 1 gig and the 10 gig and the 100 gig, and you see the little M next to it, that's the MACsec support. So once I'm connected, that's one way to do that. But how am I going to get connected? How am I going to do that? That's the next requirement. Wait, we don't have a presence in any Direct Connect location. Seriously? Okay. What can we do? Yeah, can you help me out? Well, we don't really have a way to help you out. We don't do this. But just so you know, we have partners. We have partners that can help you get a layer 2 circuit through a partner. Right? You get your layer 2 circuit towards this AWS router, and then now you should get connected. Now, you need to understand that this connection is not a dedicated connection. So you can have, through a Direct Connect delivery partner network, so there's a special tag for partners that can do this, but the way that it works is they have already a layer 2 network with you from their customer router, and they get you into their own partner router. They already are attached, because they're a delivery partner of Direct Connect, they are already attached to AWS. They already have this port that is currently in use. Maybe they have 100 gig right there. And this 100 gig connection that they currently have with AWS, 100 gigabit per second, they resell it to you. They resell a part of this connection back to you. So, as they resell that, you can have a 50 meg connection. You can have a 100 meg connection. You can have a 1 gig connection. You can have a 2 gig connection, a 5 gig connection. You can have a lot of different speeds, but there's something that is different about this. The big difference is the type of virtual interfaces that you can have when doing your connection. We'll talk about the different virtual interfaces in a moment, but when you're using something that is called a hosted connection towards this, the hosted connection is only for one virtual interface. We'll talk about the 3 types of virtual interface after: private, public, and transitive, or transit, and why we would use one versus another, but only one. So if you need more than one, based on the use cases I'm going to tell you after, just remember the fact that why would I need more than one? When I do, I need to order more ports or more speed out of this partner. So I have yet another layer 2 to get established. Layer 2. That reminds me of another joke. How do you catch an ether bunny? With an Ethernet? We're getting there. Okay, all right. We're getting there. They're all great dad jokes. I don't know. So the way that it works is you get this logical connectivity, and that's a virtual interface. You do get your VLAN towards AWS. Now, to get towards AWS, so if I go back in here, we have 2 transit gateways on this side. To be able to go from this customer router to be able to connect to the both transit gateway, so to get connected to a transit gateway in AWS via Direct Connect, you have to use a Direct Connect gateway. A Direct Connect gateway, I want you to see, it is in the AWS cloud, but it is outside of the region. So Direct Connect gateway is a construct that is outside of the region. It's a global construct. But through a Direct Connect gateway, you can attach to multiple transit gateways so that you can get to every one of these VPCs if you choose to. Now, Direct Connect gateway, well, it says it right there, to any one of the regions except the China regions. All right, so in any accounts, that's fine. So the type of virtual interface that you're going to need to be able to do that is called a transit virtual interface. You can have up to 6 transit gateways attached to a direct connect gateway. But you can have up to 4 transit virtual interfaces per direct connect gateway. So really the number that's here, I should probably say 4, but then sometimes you don't want to connect to every single one of them, you just want them to get connected and whatnot. So it's 4, 6, anyway, those are your numbers. Now that's for a transit virtual interface. Transit virtual interface equals getting connected to transit gateway. If you want to get connected towards a VPC directly, then you're going to use a private virtual interface. You can connect up to 20 VPCs through a single direct connect gateway. So if you go through a partner, right? So if we go through a partner, which if you remember, it's only a single connectivity that we have, through that single connectivity, they can get you connected to a direct connect gateway, and now you can connect to multiple VPCs. So you don't actually need to order multiple connection from the partner to connect into multiple VPCs, especially because if you go through transit gateway, then you can connect to as many VPCs as you, well, there's a limit, but you can connect to a lot of different VPCs through a transit gateway. All right, but there's a big giant void on the right side. I wonder what that is. Well, let's go and take a look. We have a new requirement. It says, we just realized Amazon S3 traffic still uses our internet connection. Why? Where does S3 live? Does S3 live in the VPC? Question mark. Or does S3 live inside of a region? In a region. So if S3 lives in a region, check mark on that side, remove it from the VPC. So if S3 lives inside of the region, S3 has public IP addresses. If my data center, if I have a small little appliance that's right there, or my laptop that's in the data center, and I would like to talk to S3, I do not go through all of this into the VPC and then get out towards the S3. It's possible, by the way. You can do that using a VPC interface endpoint. But how do we get connected to S3 without using this interface endpoint? Well, the way to do that is we're going to need the thing that's missing on this slide, which is the public virtual interface. A public virtual interface allows you to connect to all of the public IP addresses of AWS. When I say all, I mean a lot, all of AWS, all of our public IP addresses. I hope that your customer router, when we advertise these more than 3,500 different prefixes, is not going to die on the other side. That wouldn't be great. I managed routers that 1,000 was the maximum. So they blew up, didn't know. I learned my lesson. So a lot of advertised routes are being sent, but now I have a public virtual interface. Now, a public virtual interface doesn't go to Direct Connect Gateway, right? So if I'm using the partner network and I'm using the partner service delivery, I'm going to need another connection. So I can have the one connection that goes towards this Direct Connect Gateway that then allows me to go towards my transit gateways. And then if I need something for public, because I want to be able to go from on-premises directly to Dynamo, to S3, to CloudWatch, to SageMaker, to the AWS Management Console, to any public IP addresses of AWS, then I can use a public virtual interface. So that uses my Direct Connect. Why do I care about using my Direct Connect for this? Well, the reason why you care about using Direct Connect is consistent performance. That was our first reason. And the second reason, we were trying to lower the cost. Why? Because when you get out of a region, where was it? When you get out of S3, out of a region, what we charge you in data transfer out has a certain cost associated with it. But when you go through Direct Connect, the cost, or I guess it's this way. So the cost, this data transfer out, is only $1 sign. It's not actually half the cost, but it's lower than this one. So dollar sign is lower than $2 signs, right? So the data transfer charge is lower through Direct Connect, but you pay for that port. So you need to be passing a lot of traffic before it's actually an amount that is okay based on the amount of money that you're paying for the port hour and all of the amount of money that you're paying to go through all of this. But if you do your math right and then you're passing a lot of traffic, then maybe that makes sense. Typically, the reason isn't about the pricing. It's about having consistent performance. That's the real reason. It's not about lowering your cost, unless you're passing, like I said, a lot, because that single port right now, we're gonna need to make that highly available, and it won't stay a single port. I promise you that. So typically, consistent performance. All right, we got that one going. So we got a lot of prefixes that are going in there. What's next? Can you help us decide between a dedicated and a hosted connection? Interesting. What is that? Well, when I use the partner side and I was watching like this direct connect thing that's right there, I click on partners and then I was reviewing what was all in here, and then there were a few options. There was dedicated connection, there was a hosted connection, and there was even something that is called hosted virtual interfaces, hosted VIF. I want to remove one right now. Hosted VIF is no longer something you should be using. Why? Because hosted connection is better. Okay, why? The reason between these two is because the hosted VIF allowed the partner to over-provision the link. Say they had a link of 10 gig, and then they could have had 100 customers and giving them 1 gig links. Well, what if all of these customers are all going at 1 gig at the same time? Oh, sorry, I have some networking problems, probably AWS. No, that was them over-provisioning. We no longer allow the over-provisioning. That's why it says it right somewhere here. AWS no longer allows new AWS Direct Connect delivery service integration using hosted VIF. AWS recommends to use dedicated connection or hosted connection. Hence why we're not talking about hosted VIFs. So we got hosted connections where we don't allow the over-provisioning because we control it now. So they can't do the over-provisioning this time. So you have a choice, dedicated connections or hosted connections. Here's the thing, dedicated connection is the same thing as you going onto, or wherever I was getting started locations, is the same thing as you going in here and using any one of these direct connect locations. So why would I use a partner? Because the partner is going to help you. It says it right there. It says to increase capacity dedicated can be combined using link aggregation. That's fine, single customer. But the AWS Direct Connect delivery partners can help you order dedicated connections directly from the AWS console. They'll help you. So you're going to be using them to try to get towards that link. They may do the layer 2 network from your on-prem to their own router, but then from there, you're going to order yourself the connection, and you're going to pass that LOA, that letter of authorization, to them so they do the cross-connect on the other side to their router and get you connected. You are now owning the connection. So if we go back to the comparing between the two, on the left side, it's like a normal connection. It's a dedicated connection. It's like you ordering it yourself. But if you use partners, they can help you get connected to that side. Using these, you can do 110, 100 gig. If you get the 10 gig and the 100 gig, you can have MaxX support. You can have 50 virtual interfaces on this one. On the right-hand side, we have a hosted connection. The hosted connection, one virtual interface, one transit virtual interface. It's one or the other, one public virtual interface. So if you need more, you need to order more from that partner, which cannot over-provision anymore. because you're using hosted connection. And then now your port speed, 50 megs, all the way towards 10 gigs. And it's not every partner that can do 10 gigs. It's all listed on that page that I was on earlier. All right. Now, who do you call when you have a problem with a hosted connection? The partner. Who do you call when you have a problem with a dedicated connection? AWS. Well, what if I use the partner to help me get the connection? Well, now you have to call both, because we have this SLA or this service level agreement with AWS directly when using a dedicated connection, even though we use the partner. All right. Next requirement. Our information security infosec team requires all communications to be encrypted. Well, that's MACsec. And MACsec isn't currently an option for us. Thanks. So, what can we do? Well, just use an encrypted protocol. What's the big deal? Just use TLS? Yeah, but we don't trust our users. We require all communication to be encrypted. Yeah, but just make sure that you're passing encrypted protocol. Like, you should be using an encrypted protocol to talk. Yeah, but we really, really like Telnet. We really, really, really like FTP. Okay, let's add an IPsec tunnel over Direct Connect. You can. Public virtual interfaces plus site-to-site VPN. Site-to-site VPN is public IP addresses. Public IP addresses are part of the public IP address of AWS too. So then we advertise them over that way when you use a public VIF. So then you can use that, so you're using the Direct Connect over a public virtual interface to connect to the site-to-site VPN, which can either be a direct to the VPC with a VGW or through a transit gateway. But I need public IP addresses, I need a public VIF. Can you make that simpler? Sure. We're gonna add one more icon. By adding that one icon, right, see? One icon, so simple. Direct Connect gateway in the middle allows us to use private IP addresses. So by using the Direct Connect gateway in the middle in here, which is a little bit newer, right? So the public VIF, site-to-site VPN, that was there for a long time. But the using Direct Connect gateway, now this allows us via the transit virtual interface. So again, if you're using a partner and you only have one connection and use only one transit VIF, then now you can make your connection. So that's one way to solve that problem. Next problem. Okay, how can we engineer or use of AWS Direct Connect for resiliency? Because you know that, well, let's roll back a little bit. That is a port on a router in a Direct Connect location. Is that highly available? It's not highly available from a hardware perspective, from a location perspective. It's really not highly available. So we need to add some high availability in there. You ready for some big slides? Let's do that. So, first one. Let's make that a little bit more highly available across 2 Direct Connect locations. 2 Direct Connect locations were across 2 different places, so then when we can connect still to the same Direct Connect gateway, because it's a logical construct, it's a global construct, so then I can connect to both places. So now I have a port on a router in 2 locations. Is that still highly available? It's there, but we can make that better. Okay, this is a little bit better. Now we have 2 ports in 2 ports. So a port on 2 routers across 2 different AWS locations. So then we're a little bit more highly available. Now, what we do not allow you to do is we do not allow you to combine these 2 and do LACP. So we don't allow you to do a lag across these 2. If you want to do a lag to increase your connectivity, you can order 2 100 gig links, if you want to, together on the same router and then LACP them, and then now you get 200 gig of bandwidth. I'm going to show you how to cheat a little bit and then not use LACP, but then add a little bit more to that. But we're going to come back to this. So that's how you add resiliency. So remember what I told you about earlier, about the data transfer charge outbound being lower? Well, now on top of that, you're paying for 1, 2, 3, 4 ports hour, two equipment inside of that location, another cage inside of that location, plus all of these links that needs to be different. You're not saving money. Like, I'm just saying, you're not saving money unless you're passing. I don't know how much traffic you're passing, but I cannot see how you could be saving money. So it's not about saving money. It's about consistent performance and high availability right now, or high resiliency. Okay, I got that. But here's the next thing. Our data centers are interconnected, and we want to advertise the same networks, because I'm lazy, over all our AWS Direct Connect virtual interfaces. How do we control routing? Because I got the 172.16.0.0/24 over into corporate data center 1, and I don't want to control where I advertise these IP addresses. I'm advertising it from everywhere, from this customer router and that customer router. So you see, we've advertised it twice. Now, here's the thing, though. Our data centers, they are connected. So because of that, then maybe you're going to be able to go through this side. But that's not a very efficient path. Because the corporate data center 2 is in the US and the corporate data center 1 is in Europe. So then now, from the region that may be in Europe, we're passing through the US to be able to send the traffic back to Europe. So we're crossing the Atlantic twice. How do we control the routing? You're making this complex. Fine. So, how you control the routing is by using communities. There's a few communities, or BGP communities, that are a little bit special, and here they are. So 7224:73. I know this is really small. I can try to double tap and make it bigger. But 73. And then on the bottom side, I'm going to put 71. So there's 7100, there's 7200, which is medium, low is 71, lowest, 72 is medium, 73 is the highest. So highest priority, which means that now the traffic is going to be sent to reach it always using this link. But if that link was to go away, right, we put a huge X on there, then we're going to use the other side and use your link between your two data centers to get the access. So that's how it could work. Why not different AS numbers is the question. Yes, you can add and then use, it's not just about the community, but there's another reason. I'll come back, because I have a real reason as to why I'm showing you all this. Isn't it missing a few things in my diagram right now? Wasn't there a lot more earlier? Let's add this a lot more. Now by adding this a lot more at the bottom, I will also advertise the same thing, but look at what the number that I just advertised. The same thing. And by advertising this same thing, we will do equal cost multipath. That's the reason. So now, yes, I can't do LACP. Yes, I can't lag them, but now we're going to load balance across these two. So we're using at least the both sides to be able to reach that same network. And then we'll do the same thing at the bottom. And there you go. So then we're just advertising the same number, again, for our local community. All right. I got some IP addresses, so I gotta have a joke for you. This one is an old one, though. In IPv4, a space walks into a bar and orders a cider. I'm exhausted. Okay? It's an older one, right? This one is a little bit older, so I had to fetch far from that one. Next one, exchanging traffic. We have a few locations with AWS Direct connections. Can we use your backbone to exchange traffic between them? What do you mean? You got a link. It's right there. Yeah, but I don't have that link anymore. Can you please help me? Wait, Call your ISP. Well, yeah, but I'm already connected to you. Can you help me out? Sure. Direct Connect Gateway does not allow the traffic to go in between your two data centers, even though they are connected. But if you change one small little setting that says Site Link, it's now connected. By using Site Link, now your two data centers are connected via Direct Connect Gateway. Remember, Direct Connect Gateway does not live in a region. It is a global construct, which means that now AWS is playing in the ISP game, sure, but the traffic is going to go through our edge locations to be able to hit in between your two data centers. So you can use us to transfer data across your two data centers. So that's Site Link. Okay, so I've now removed the link that was on the right-hand side. We're getting there, right? We're trying to get towards the AWS. Remember that first slide that I showed you where it was full of links everywhere, but at some point AWS became in the middle? So that's what I'm trying to do now, of adding a bunch of features one after the other by having AWS be in the middle of your WAN. That's the interesting part. We got a next question here. Now, can you help us simplify everything? Come on, I give you a ton of different things to use, Transit Gateway, and then you can use Direct Connect Gateway in a bunch of different ways, and then you get your Direct Connect connected, and then your site-to-site VPN, and then your client VPN. And by the way, Transit Gateway also supports SD-WAN appliances, so you can get that connected towards it and get 50 gig of throughput if you want to, for those SD-WAN appliances you already have at remote offices or branch office. Yeah, but that's a lot of work. Transit Gateway is a regional construct, which means that because it's inside of one region, now I need to do a lot of routing, a lot of routes. That's a lot of work. Can you please make that so much simpler? Sure. Because we have all of this that is really difficult to do. So we got software-defined wide area network, we got the client VPN, we have an increase in security, we have users everywhere that are connected over a client VPN, we have applications in the cloud, applications that are on-prem, global availability that we need to have this in seconds, that's everywhere. So can you please make this a lot simpler, because like, this is a lot of work. Sure, that's AWS Cloud One. AWS Cloud One makes a lot of this automatically for you. So it takes care of a transit gateway automatically for you. It takes care of the SD-WAN part of the transit gateway for you. It takes care of client VPN for you. It's somewhat of a managed service of our already managed service that was transit gateway. So managed square service, I should be in marketing. So that's the Cloud One. But the thing is, sometimes you have different segments, so production, development, and testing. So the way that it works with Cloud One is you can create multiple segments and you can decide what can talk to what. And on top of that, as things gets added, as new VPCs gets added, you can tag your VPC with something, and then as you tag that VPC, it will get automatically added to this Cloud One thing. The whole idea is that as I add new resources with the proper tagging, I create policies and whatnot, we'll see that in a second, then I can add all of this automatically into my network. That's the idea. Now, one thing though that you need to be aware, which is the Direct Connect side, Direct Connect has to pass through a transit gateway that you manage to be able to connect to Cloud One. It does not have a direct connection. That's weird. It doesn't have a direct integration with Cloud One yet. We said that last year. We're saying that again this year. But you have to go through a transit gateway that you're managing. Now, what if I have already some transit gateways? I have a brown field, not a green field, it's a brown field. So, and I got a bunch of transit gateway that are already set up, but I want to use Cloud One. Because there's nothing wrong about doing it yourself. But if you want to use Transit Gateway, if you want to use Cloud One and you're already using Transit Gateway, one thing that you have to be aware is you can have both at the same time, establish the both and get them ready, create your Cloud One, create your different segments, associate them properly, and then even though it's there, it is going to only have propagated route, and AWS will prefer, well, Transit Gateway will prefer the routes of itself, whatever you have done inside of the route tables, versus whatever is being propagated from the AWS Cloud 1. So that's how you can be in brownfield and in between the two. So that's the first thing. And then as time goes on, after your migration, you just make sure that you remove all of these route entries on that side, and then now it's going to start using whatever was inside of the Cloud 1. So you can do that on a per route table perspective and start deleting the route entries on each one of them. So that's possible. The other thing that you can do is there's still nothing wrong with using still your Transit Gateway that you are managing. Why would you want to do that? Because using Transit Gateway directly offers you more flexibility over what you're using. So by allowing you that more flexibility, there's reasons, right? You want to use Transit Gateway, you want to tweak certain settings, but Cloud 1 doesn't allow you to tweak these settings, so you want to continue into using the Transit Gateway. You can get them federated. That's what we call it. When you federate them, it gets attached to your Cloud 1, so they're half managed. So they get connected to your Cloud 1, so it makes it a little bit easier. There's some Transit Gateways that are managed, some others that are not. But behind the scene, that's what it uses. So how does it get automatically connected? The Cloud 1 attachment policies, that's what we're using. So the attachment policies, what we use is a tag, and then you add the tag to the thing that you're creating. So right now I've created a policy attachment. That's really small. Let's go this way. So I created a attachment policy, production, and I call that if tag value equals key environment value production. So because I've attached to this VPC the tag environment : production, then as soon as I create this VPC, it's going to attach it. This works across AWS accounts as well, and then, well, of course, across region. So then Cloud 1 can be across all of your different regions, across all of your different VPCs that you're creating. We're done, right? That was enough. Whew. But DNS is still part of networking. What? Oh, I know. But what's a DNS favorite type of music? Anything good with resolution? No? Oh, okay. All right. I'm going to work on that one. So now we have connectivity sorted out. What about DNS? I want to be able to resolve DNS across. Well, the way that we do that is via resolver endpoints. The way that it works is because I have this hybrid connectivity now, multiple VPCs, as you see it, multiple VPCs. I got a resolver that is on premises, is managed by the network team, of course, because that's where DNS lives. And then that has a special IP address that's right there. And then we even have a server that's on that side. And then I have also an EC2 instance on this side and inside of that VPC. So how do I get these to exchange DNS entries? Well, what I'm going to do is this server is querying for server.example.internal. Example.internal is what this DNS resolver is responsible for. So what I'm going to do is, next step, this goes to the resolver inside of the VPC, the +2 of the subnet. That's our DNS resolver. This will talk to something that's called an outbound from the VPC out resolver. This resolver endpoint points towards forward rules. The forward rule says anything that says example.internal, forward it to this IP address. That IP address is the IP address of our DNS server on the right-hand side. And then because we have a hybrid connectivity over Direct Connect or VPN, we can send the connection over to the other side, and then now we got our answer. Let's do the other side now. The other side, we have this server on the right-hand side that asks for server.example.aws. This is a private hosted zone in Route 53, example.aws. Now that I have a private hosted zone, I want to be able to communicate with this. But this thing, I can access it only via the DNS resolver that is inside of the VPC. I can attach this private hosted zone to the other VPCs if I want to, but you can only talk to it via something that is from within the VPC. So how do I make it seem like this resolver is inside of the VPC? Well, to do that, sure, the example, the query goes to the DNS resolver. To do that, we need an inbound route 50 resolver. Inbound because it comes from the outside in. All right, inbound, that's the way. All right, inbound. It has an IP address, by the way. And this IP address is the thing I'm going to configure as my forwarding rule on site, on-prem. So example.aws lives, all zones, everything, every DNS records for this should be sent to that IP address, which is a resolver endpoint. And then now the query is going to go to the resolver endpoint, which is then going to be able to hit the private hosted zone because it lives in an E and I inside of the VPC. Okay, but what about all of the other VPCs? How will they be able to connect to all of these? Well, we have RAM. Resource Access Manager allows you to attach the forwarder rules in between every single one of the VPCs that you're creating. So that's how you can share the outbound rule for all VPCs. The inbound rule, there's no point into trying to share it across all VPCs. And it's the Route 50, the private hosted zone is a construct. Again, that shouldn't live inside of the region. It should live outside. I missed that diagram, I'm sorry. But that private hosted zone should be outside of the region, and that's why it doesn't matter where it lives. It lives inside of an account, but inbound, you only need one. Well, two to make it highly available inside of the VPC. But outside, for an outbound perspective, you share in RAM the resolver rules, and that's it. So, what we've learned? A lot of different things. Hybrid networking is what we've learned, but start with site-to-site VPN. Okay, maybe you should be using site-to-site VPN with Transit Gateway. Then we went over into client VPNs, direct connect, connecting your traffic with high availability, accelerated VPN using Global Accelerator, Cloud One to simplify everything because it's getting really difficult, and then finally we got the resolver endpoint. So that's what we learned today. There's a lot more classes that exist, 500 different classes that exist in AWS in Skill Builder. I have 2 classes if you're interested to learn more about networking. If you're going to take these as a picture. I may have been on one of them, so maybe I'm doing some self-promotion, but no one has to know. And then there is this week reinvent.labs.awsevents.com. You can do over 100 different labs if you want to on your laptop, or you can go to our self-paced lab. If you go to self-paced lab, it's the same place, or you can do these in your hotel room. You can do that all the way until the end of the week, any of the labs. So you don't need to go to our self-paced room to do that, but you should, because I want to say hi to you. Other than that, there is oops, that's not the one. This one here, 7-day trial for Skill Builder if you want to do labs after the fact, for free for 7 days. And then that's the thing there. Thank you, everyone. Sorry.